Hello and welcome everyone to today's webinar, OraOperator, Autonomous Database Management in Kubernetes Redefined. My name is Nikki Chen and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today, we're excited to show you what challenges OraOperator can solve for developers. We'll be recording today's session and we'll be sending the replay to the same email address used for today's event. If you have any questions during the webinar, please drop them in the Zoom chat and in the Q&A area, and we'll be ready to help you answer them. We'll also set up a Slack channel, Oracle Autonomous Database, in our developer workspace that you can access at the QR code or at the link on the screen. This channel will remain open after the event for you to contact us directly with any questions and to share any resources with you. Today's webinar will be presented by Herman Viscuso, Director of Developer Community. With that being said, I'll hand it off to Herman.
Okay. Hello, folks. Thank you, Nikki, for the introduction. So I've been working with Autonomous Database for a long time now. My name is Herman Viscuso, and I'm a PM and also handling the developer community around Autonomous. We think that there are a lot of advantages in Autonomous for developers. One of them is that it could be easily operated within Kubernetes thanks to OraOperator, or the Oracle Database Operator for Kubernetes. This is why I say that this is like database management in Kubernetes redefined, because the OraOperator makes things super easy. And we will go through a few slides, and then we'll go through a live demo. So this is first part slides, second part live demo. But I'm planning to do more sessions. Like I will go through a part 2 and a part 3. So if you like this one, please keep an eye on the upcoming sessions where we will work towards the advantages for developers in doing CI/CD and trying to quickly deploy databases and destroy them and integrate them with their CI/CD pipelines, etc. Okay, so this is part 1, and we'll have to set everything up to work with OraOperator, right? All right, so let's move forward. Okay, so just one sec. So if you develop microservices, you are probably familiar with what you're seeing right now. We use several frameworks as developers that you can see on the left to create and orchestrate those microservices. You might be familiar with Spring Boot, for example, Helidon, etc., etc. So if we are deploying microservices in production and we are being serious about it, we are usually also doing DevOps, right? DevOps processes. We have DevOps processes in place like CI/CD. And for example, you can see there in one of the boxes, GitHub, right? And one of the things that I will be showing in part 2 of this series is actually how to set up GitHub hooks to actually connect it to Jenkins and create and destroy databases based on those hooks. And things like that are usually in place and are very important for test dev environments. And then we have an application infrastructure that you can see in the big box there. Where we probably have at least a containers platform, right? Could be, for example, a Kubernetes cluster. And you also have network and traffic setup, because you usually need, gateways. You usually need load balancers to basically make this work at the network level. And obviously, storage and databases, which is one of the main points that we will cover today, right? So note that there's also a big presence. If you take a look at the bottom of the slide, there's also a big presence of security-related elements and observability. And observability is one of the things that I'm focusing on these days, and we'll take a brief look at observability in a setup like this in a few slides. All right. So this is just to set the context of the kind of platform that we are talking about. Now, you can of course use OCI to materialize this architecture, because with OCI you not only get the infra, but also all the associated tools that we will be talking about and frameworks, etc. because one of the main goals of OCI is to rely on open standards, and we are using a lot of open standards for example, in observability, we are relying on open telemetry. To give you an idea, our functions system is basically, based on an open source project, and so on and so forth. In general, we try to be open when it comes to the tools and things that we use within OCI. So, for example, your OKE cluster here, which is right there in the middle of the slide, is a full-blown Kubernetes cluster, right? You can optionally upgrade it to an enhanced cluster thanks to one of Oracle improvements within OCI, but this is basically the real thing, a full-blown Kubernetes cluster that you can use in the same way in which you use any Kubernetes cluster deployed in any cloud or even local, right? Okay, so let's keep going. So I mentioned storage and databases, and it's something that you have to have. I mean, you won't have a microservice that is not using storage or a database behind the curtains, right? Because you need to basically store the data. So let's talk about supporting data storage in multiple microservices. This is a slide where you can see that we are using multiple data types and multiple types of databases depending on the microservice. We usually see this problem, and we see it in production, where we have a special database per microservice, or a database type per microservice approach. So we are often recommended a specific type of database technology for a specific type of microservice. We go with that, and that introduces some issues and some problems. Okay. One of the things that we are trying to do, and that we understood a long time ago at Oracle and with the Oracle database architecture, is the advantages of containerized architectures. Okay, so before containers were popular, we introduced this pluggable architecture where you have the database instances being pluggable databases, and we have a big container or CDB or container database that is basically making it easier for things to happen at the container level. So, for example, you don't have to go and do stuff within every instance, but you can, for example, do patching or other maintenance operations at the CDB level, and you don't care about each single, instance. So, Autonomous Database is using this pluggable architecture. And autonomous database is also using the converged database. So as you can see there in those cylinders in this slide, you can have different database instances supporting different microservices or different applications, if you want, with different data types, which are convenient for a specific microservice. But you have the same underlying architecture. You deal with security in the same way. You deal with maintenance in the same way. So you don't have to basically have different expertise for different kind of databases. I mentioned Autonomous Database. And now for those of you that are not familiar with Autonomous Database, I would like to say that Autonomous Database is the Oracle database engine behind the curtains. It is using converge capabilities. So basically it handles multiple different data types. For example, can handle JSON natively. But it's a cloud native service. Autonomous Database is running in the cloud as a database service. Now, why autonomous? Because we added a layer of automation on top, a machine learning. So you don't have to worry about a lot of things that you will have to worry about with an on-prem system. Right? A lot of things are happening automatically for you. Automatic indexing, automatic scaling, if you configure it. For example, being self-fix or self-fixing when there are issues, etc., etc., etc. So let's say that is as I'm saying there in the slide, it's like the fusion of the best of database, cloud, and machine learning technology for the 21st century. We think that this is a very big trend where all database systems will go, right? And basically Autonomous Database is the pioneer in this area. All right, so enough of autonomous. The Oracle database operator for Kubernetes. Okay. So when we use the cloud 100% to build and run our applications, we're basically doing cloud native computing, right? We call this cloud native computing. It's a trend today. There are standards, et cetera, et cetera. A lot of organization basically promoting cloud native, like the Cloud Native Foundation, for example. And for this type of development, Kubernetes is usually at the center stage. Now, when Kubernetes is used to orchestrate our apps, we need to understand a few important points. And these are basically points that I am providing to you if you're not super familiar with Kubernetes right now, okay? So Kubernetes is an extensible manager. It's very versatile, and that's why, for example, we can extend it to control Oracle databases because we can extend the API of Kubernetes and what Kubernetes can do in terms of controlling things to basically go beyond what's being prepared for. Okay, so it's also used as a very simple. It also uses a very simple and declarative language called YAML. I'm not sure if you're familiar with YAML, but we basically apply the specs defining these YAMLs, and Kubernetes will honor those specs and will try to keep them within spec. Okay, and this is something important because this is not only applying and just doing a hit and run and applying something and then I'm not monitoring it, but basically the system is making sure that we are honoring those specs and it's doing a loop, as you can see there, where we are observing, analyzing, and acting. Okay, so it's doing that in a constant loop, as I said, where all the resources are being monitored and compared against these YAML specs. So this is also a control system. It's not only an apply system, to put it some way. So when extended, as I mentioned before, it can do more stuff. For example, we can extend it to manage credentials, which we will do during the demo, and we can extend it to manage Oracle databases, which we will do when we apply the Oracle database operator. And it can also natively handle secrets, and we will be using that functionality too. Okay, so keep an eye on this control loop by Kubernetes. Why do we need an operator? Okay, and sorry if I'm going a little bit fast, but basically I want to get to the demo because I think that's where you will get the most out of this presentation. But first of all, why are we talking about an Oracle Kubernetes operator for the Oracle database? So we need to support Oracle database services within Kubernetes because we want to bring Oracle database lifecycle management to Kubernetes, and we want to do it with the whole offering on the Oracle database side. So this operator will not only manage, will be able to deploy Oracle database images for you, deploy them, fetch them, deploy them, and create them and destroy them. But also, it will be able to connect to database services running within OCI, like for example, autonomous database, and you will handle them transparently, as if they are, your typical database. It doesn't matter where they are. Okay. So it's easy to manage. It's basically using a stateful application within Kubernetes. It's using an operator. I'm not sure if you're familiar with operators within Kubernetes, but this basically provides a database operator within Kubernetes to be able to handle the whole lifecycle management. It allows you to create databases. For example, we will be creating an autonomous database within the Kubernetes thanks to the operator, but it also allows you to bind databases. Like for example, suppose that you already have a database and you want to connect it and make it visible in the operator, you can actually go ahead and do that. It's not that you can only work with databases created from the operator. And this is all designed to support demand creation of test environments like in CI/CD. You can easily connect this to CI/CD processes to basically create databases, bind databases, destroy them when they are not available, operate over the databases, maybe do backups, maybe scale the databases, and everything is connected to your CI/CD processes. Okay, so thanks to the OraOperator, the Oracle database becomes part of the Kubernetes infrastructure. You can do start, stop, monitor, patch, upgrade, the whole set of lifecycle, operations, and it covers multiple types of databases. Could be on-premises, could be database services, could be single instance databases, could be the latest 23C image that you might want to deploy and then destroy, etc., etc. It's very versatile. right? So that's why we created OraOperator. But by the way, this is an open source project. You can actually go. I have a slide where I'm basically showing, how you can go and contribute, and it's fully open source. You can see the whole source code is out there. Okay, so let's just give me one sec. Okay. So far, so good. Okay, so this is the like a view of basically how it works. You can see that we will be installing the Oracle database operator. There's a line there that says kubectl apply -f. So that's all it takes to actually install the operator in your Kubernetes environment. So if you have a Kubernetes cluster right now, you need 2 lines to install the Oracle operator. You need to install Cert Manager. We will take a closer look at that. And you need to run this line here, which is basically the YAML that applies the operator. Once that's done, you have all the things that you need in your Kubernetes cluster to be managing Oracle databases. So as you can see, there are a set of controllers there. You see like red arrows going out of these controllers. These will be installed when you install the operator. And with those controllers, we'll be able to control a specific type of databases, like multi-tenant databases, base DB, autonomous database, et cetera, et cetera. Okay, and also containerized databases, which is something that I mentioned before. Now, observability. Observability is very important. Observability is going to be added in version 1.1.0 of the OraOperator. We are in version 1.0.0 right now. This is coming really soon. That's why I decided to actually mention observability and show you a little bit of how it works. But this is coming very, very, very soon. Okay, so keep an eye on that project that I will share later for observability stuff. Okay, now we will be using Kubernetes in an OKE cluster, so we will be within OCI, but this could be your own Kubernetes cluster running somewhere else. It doesn't have to be within OCI. All right, okay. All right, so let's keep moving. So this is a view of what's supported right now. You might be asking yourself, okay, if I have, I don't know, base DB, for example, what can I do with the operator? Or if I have autonomous database, what can I do with the operator today? So this is an overview of what you can do. As you can see, we have great break coverage. We will also provide data guard support. Right now, it's actually in preview, but you will be able to handle data guard lifecycle operations within the operator. But the point where I want to focus on today is basically autonomous databases. As you can see, you can provision autonomous databases. You can bind autonomous databases, start, stop, terminate them. You can scale them. And in the demo, we will scale one autonomous database with the operator. And you can deal with some network access options. And you can also do backup and restore. We will not be doing backup and restore during the demo, right? So as you can see, this is growing and it will keep growing. And when here you're not seeing observability functionality, but when you add observability functionality, you have a really, really good operator for if you're dealing with Oracle databases in your Kubernetes environments, okay? So let's talk a little bit about CI/CD. And what is it that the operator can come and solve for me if I'm doing DevOps, okay? So developers are not DBAs. Developers do not want to wait for a DBA to actually provision a database for a specific test environment. They want to go self-service, right? They want to be able to create and deploy databases and destroy them on demand. So this is what OraOperator is trying to fix here. They don't want, as I mentioned before, integration by the DBA or wait for specific things to happen because that could very well be a big problem when you need to coordinate that with automation processes, right? Kind of go manual there. Schema changes can be basically orchestrated by the operator and within your CI/CD processes, so you can apply a specific schema to basically try out things, maybe a new schema, etc. And in general, developers don't want to be waiting for the database to be ready. Okay, they need to launch these automated processes, and the database should be handled from within those processes. So this is the idea. automation and continuous delivery, continuous integration. Okay. So the OraOperator, as I mentioned before, is open source. This is the project where you can contribute to. You can scan the QR, or you can go straight into this GitHub repo. Contributions are welcome, and you can take a look at everything that can be handled from the operator. And very soon here, you will see the addition of the observability functionality that I mentioned before. Okay. All right. So to give you an idea, and this is something that I will be showing in part 2 of this session. So we will have a part 2, hopefully in one or 2 months, right? I prefer 1, but let's see what the availability is for the slots. But we will be seeing and setting up Jenkins with a branching strategy. So when you have a code and you create a branch, a feature branch, for example, within the code, we will set things up so Jenkins can actually deploy a specific database for that branch to test how the branch works, those modifications in that feature branch. Test it out, you can see if it works correctly, etc. And then when you merge that branch and you say, okay, this is working great, I want to merge it into the main branch. When you merge it, the database will get destroyed for you, will be destroyed for you, and everything will be done automatically for you. You don't have to deal with the database at all, right? It's all part of the CI/CD processes that you're running within Jenkins, right? So stay tuned for part 2 of this. I wanted to show it today, but this requires a lot of setup, right? So there will be no time to do the intro to OraOperator and also show you all the Jenkins stuff. So it's there, it's up and running, but basically we don't have enough time to show it today. All right, so let's keep moving. Let's talk about observability. So you have the operator up and running, and you want to have observability over the database. And as you know, the 3 pillars of observability are tracing, metrics, and logs, right? So tracing, metrics, and logs. Those are the 3 things that we all want to do when it comes to observability. And when we were talking about performance metrics from the database, that's something that it's super important, because basically allows us to know what's going on with the database, right? We want to see how our maybe performance is doing, how our CPUs is doing, how we're doing it with storage, etc., etc. Also, accessing the logs is super important, because that might provide us with insight into what's going on. And then tracing is super important, because we might want to try to understand when something happened, there's some error or something happening that it's out of place at the application level. How is that related to the database? How can we go from the application error all the way to the database and maybe to specific log within the database that is showing that something wrong is going on? This is what this unified observability project is enabling for us. And it's all based on open standards. It's using open telemetry. It's running a set of exporters within Kubernetes that will export that information from the databases and make them available to open platforms like Prometheus and Grafana, for example, that you can see there, that can be deployed automatically within your own Kubernetes system. So when you enable, right now, as I mentioned before, this is not available within the operator right now, but it will be available, and it will be a convenience way to deploy all of this at once. So basically, you would enable observability within OraOperator. All the exporters will be put in place to basically export that data from the database, and all that you need on top, like Jaeger, Prometheus, Grafana, will be deployed in specific pods within your Kubernetes architecture for you to be able to use them. And basically maybe create a dashboard, out of what's going on with the database, et cetera, et cetera. So this is available right now, but it's available standalone. You can go to that top link at the top right, and you can try it out. There are also sessions that I did showing how to install it, how to use it. But think about the convenience of just hitting one line of code saying enable this in the OraOperator, and you get all of this in the OraOperator. That's the point of version 1.1.0 coming very, very soon. All right. So let's keep going. So I want to go through observability, showing how it works within the OraOperator in part 3. Obviously, I need it to be available within the operator, but I will go through it in part 3. This is a little bit of the details of how the exporters work. I don't think this is important right now, but basically there's a time series database called Prometheus that is basically doing scraping over the what the exporters are exposing from the database. So the exporters are getting performance metrics, are putting them in a format that is understandable by Prometheus. Prometheus scrapes that information, puts it in the database. So Prometheus is the time series database, and then Grafana connects to Prometheus to basically show all that information in dashboards. Okay. All right. So this is how you can contribute to the observability effort. This is another project. It's also called usually Unified Observability. You are also invited to contribute to this project, okay? All right. So I'm going to run a demo, but I did some things beforehand because I needed to deploy infrastructure, okay? So if you want to deploy the things that I deployed beforehand, which is what I'm showing here, I created a group, I created a policy, I created an API key within OCI, I cloned a repository, I created the OKE cluster because I need a cluster to basically install the OraOperator, right? So I need a cluster up and running. And I created a Kubernetes config within Cloud Shell, and I initialized the cluster. So what I did, all of these steps that I have already done, is basically creating a cluster for me to be there and up and running, for me to go ahead and install the operator, show how it's managed, how we can work with it, etc., etc. So I needed a cluster, right? So if you are interested in doing this from scratch, all of these steps, you can go to the link at the top right and do lab 1. Okay, you need to do lab 1 of that live lab, and you will be able to do all of this and set it up, right? So I'm going to go through these steps now within the demo. I'm going to install and configure the OraOperator. I'm going to install Cert Manager, which is a prerequisite for the OraOperator. I'm going to create credentials. We need credentials to access OCI, because if I want to work with ADB is within OCI, so I will have to access OCI. So for that, I will have like a private key to connect to it. I will also set up secrets, like the administrative password for the database, stuff like that. We will go through a YAML that creates an autonomous database. We will generate that YAML. I will show it to you. We will apply that YAML. Then what we will do is we will ask the OraOperator to to fetch the wallet from the database. So this is one of the really good things about OraOperator. When it's working with a service like Autonomous Database, it will also handle the wallet for you, okay? So we will do that. We will initialize ADB for Cloud Bank, which is a very simple microservice-based application where you have a bank A account and a bank B account, and you can transfer money from one bank to the other. So it's really like a toy setup. It's very, very, very simple. We will be initializing then ADB to be behind the curtains of that microservice. We will scale ADB just for demonstration purposes. We will scale it using OraOperator. We will extract the wallet, okay, from OraOperator, take it to our local machine, which in this case will be Cloud Shell, and we will connect to the database, okay? Yeah. So I wanted to show you that you can basically connect to the database as you will do from any database, but you get everything from OraOperator, okay? Finally, if we have time, we will be on deploy Cloud Bank. So it's just running a couple of scripts just to show you what Cloud Bank is, but that's not super important because we are not focusing on the microservice here. We are focusing on the OraOperator itself, okay? So I'm going to switch my screen right now. So let me just stop sharing. Okay, I will share again. Let's share desktop 3. Okay. So you should be seeing right now, 1 sec. You should be seeing the cloud.oracle.com. I'm within OCI, okay? And basically, I'm showing you that I am in the autonomous database section. So if you type autonomous, you will see, and here I have like a terminated terminated database. Let me see if I can see it right now, or it disappeared. There you go, terminated. And what I did here is I went to Cloud Shell. I click here, Cloud Shell, and I'm in a shell. So this is a shell that you have within OCI for you to basically work from the command line, and we will be working from the command line, okay? Okay, so let's get started. I told you that we had to install, so just let me go to the right part. Just give me 1 sec. I told you that we had to install Cert Manager, right? All right. So, okay. So let's install Cert Manager. So Cert Manager is allows us to deal with certificates. It's not an Oracle project. So let's go do this. Let's go big, right? And as you can see, I'm basically using a kubectl. Let's go there. I'm missing the K there. I'm using kubectl to apply a YAML. So as I told you before, kubectl stands for Kubernetes control, and it's usually used most of the time to apply a specific YAML. So we will apply the one that installs Cert Manager. So let's go ahead and do that. Okay. So as you can see, it worked. And if you want to verify that Cert Manager is installed, remember that this is a prerequisite for OraOperator, so we'll have to do it. We can run get deploy and ask for that namespace Cert Manager to see if it's here. And you should see all ones here. We can see that on the first one we see 0, 1. We need to see all ones. So let's ask for it again. There you go. 1, 1, 1, 1, 1, 1. This is what you should be looking at to say, okay, Cert Manager is installed. All of them ready. 1, 1, 1, 1, 1, 1, right? All right, so now that we have this prerequisite, we can just go ahead and install the operator. And this you can do in any Kubernetes cluster. It's not in a cluster. It doesn't have to be a cluster running within OCI. You can go ahead and do this in any Kubernetes cluster. And this is the way in which you install the operator. You apply a YAML, and we are getting the YAML straight from the project, the open source project that I mentioned before, okay? So I'm going to apply it. And remember that all of this is live. I'm not sure if this is going to go smoothly. I hope so, but all of this is 100% live. We hope we don't run into any issues with the deployments, et cetera, et cetera. So as you can see, we created a whole bunch of things. So if you want to verify that this is up and running, you can get the pods. Like, for example, you can do kubectl get pods and basically ask for Oracle Database Operator System, which is the system. And when we do this, you see that we also get all ready 1, 1s. And this is what you want to see here. You want to see ready 1, 1, 1, 1, 1, 1. Okay. Okay. So we have the 3 elements running. And you might wonder, okay, what is it that I can do now that I have the operator? There's a way for you to check the resources that the operator is providing, okay? So if you do this, like kubectl API resources, API group database oracle.com, you will basically get a list of resources that the operator just added, okay? And as you can see, we extended the API of Kubernetes, and now we can deal with autonomous container databases, autonomous database backup, autonomous database restore, autonomous database. We can deal with CDBs. We can deal with data guard brokers, DBCS system, Oracle REST data service, PDBs, sharding database, and single instance databases, right? So we have just extended the Kubernetes cluster with all of this OraOperator resources. Now what we're going to do is we are going to prepare things for ADB creation. And we are going to create something called OCI cred. I mean, I call it OCI cred, which is a set of information with info and credentials so that OraOperator can connect to OCI. So I want OraOperator to be able to connect to OCI. Suppose that we need to extract the wallet of a specific database. We need to connect to OCI. Obviously, we need to create a database, an ADB. We need to connect to OCI. So I'm going to run that command here. And this is basically creating a config map. I'm not sure if you're familiar with config map, but it's basically a structure that holds several parameters and resources. Here I have the tenancy ID within OCI. Here I have my user ID within OCI. I have a fingerprint for the API key. and I also have a region identifier. I'm working in Ashburn right now, as you can see there in the top right. All right, so we are going to create a secret right now, which will be pointing to the private key of the API. Because when I created the API key within OCI, I basically took the private key, and I need to provide that private key to the OraOperator. So that's what I'm going to do. And I'm going to say, I'm going to do this, right? So I'm going to, I'm creating a secret here, and I'm saying, hey, the private key file is this private PEM file, okay? And I have it here. I already uploaded it to Cloud Shell. If you click here on the gear, you can do download and upload files. You can upload private PEM here. I already did that. I have it sitting right here in my home directory in Cloud Shell. Okay. All right. Now I'm going to create a secret, which is the admin password to connect to the database, right? And this is a secret within the Kubernetes cluster, right? So I can basically work with it as with any secret within the Kubernetes cluster. So I create the admin password. There was a step that I did not show, which was done in lab 1, which is all the setup of the Kubernetes cluster, where I provided this information in variables, and now they're being extracted. Sorry. For example, I provided a password that the database should have. I provided the OCID of the tenancy. I provided the OCID of the compartment that I'm working with. So basically, the system within lab 1 collects a whole set of information that now can be magically referenced with these commands, okay? So I did this in lab 1. All right, so now what we're going to do is we are going to go to the workshop directory, and we are going to create a YAML to create an autonomous database. So there's a command here that basically creates a YAML for you. I'm going to run it, right? Let's see. So it created it, and it's telling me, okay, now you can apply it with this command. And I wanted to show the YAML to you, so you understand what we're talking about and what will happen when we apply this YAML, okay? All right. So this is the YAML, and as you can see, we're saying, you know, I want an autonomous database. I want the name to be CloudBankDB. The namespace is CloudBank. The compartment OSID is this. That is why we created, we've just run a script to create this YAML, because the script is basically going to take a look at, oh, what's the compartment OCID, and I'm going to put it here in this YAML, okay? And this is what the display name is going to be. And also, you know, we are using the admin password that I created in those secrets. And I want this to be 1 CPU, and I want this to be 1 terabyte in storage, okay? And this is the way in which you connect to OCI, just all the credentials, etc. So the YAML is very, very simple. And this is enough to apply it and create an autonomous database. That's all we have to do. So let's go ahead and do that. Okay. Let's just say, let's just copy the apply command from here. Okay. Okay. Apply. And now, just give me 1 sec. Now, suppose that you want to verify what's going on, right? Just apply it. There should be an autonomous database being created, right? So let's see if we can see it here. I'm not sure why I'm getting. So as you can see, it is provisioning right now. If you had a look before, I had this terminated instance, which is from a previous run that I did. But basically, this one just appeared, and it's provisioning right now. This is thanks to this apply that we did here. You can also verify it here in the command line by doing kubectl get autonomous database. So you will see that we get a line saying CloudBankDB. This is the YAML that we just applied, and it says provisioning, right? It's provisioning. So we need this to be available for us to continue, okay? So what I'm going to do is, because this takes 2 minutes, right? What I'm going to do is I'm going to show you something. Let's go quickly to the Kubernetes cluster that I have up and running. So this is the cluster that we're working with. And here you have something that says upgrade to enhanced cluster. So this is something that you can also do. And you have here a definition of the node pools, and you have add-ons here, okay? So when there's no button here that allows you to add an add-on, right? When you go and you click here on upgrade and enhance cluster, I don't want to do that right now, but in add-ons, you will see a button that allows you to add add-ons. And you can, for example, add the cert manager that we added via command line, and you can add OraOperator that we added via command line. So you can also do this via UI if you want to say, okay, I have my cluster within OCI, and I want to install cert manager and OraOperator via OCI, just the UI. You can do that, but know that there's no button here because you need to upgrade to the enhanced clusters. And when you do that, you can basically manage add-ons from here. You can click on add an add-on, go ahead and install those two, and then you are up and running within your cluster. That's if it's within OCI, okay? All right, so let's go back to autonomous. Okay, so it's available. So we keep going. If you do this command, like describe, for example, the describe command, describe, we can actually take a look at a lot of information from the database, okay? So you can see the OSID, you can see that it's available, etc. But also you can see all the connection strings. So you have the connection strings to actually connect to it, right? You will score, of course, need the wallet, but you have everything. All right, so the command, just if you didn't have a chance to catch it, was kubectl describe ADB and the name of the database, CloudBankDB, right? So let's keep going. Now what we're going to do is we are going to pass a password for the wallet creation. So we are going to do this. We are also going to create a secret, and we are going to define what the password will be for the database, okay? But this is not the admin password. This is the connection password, okay? All right, so that's created. And we could generate, we can apply a YAML to actually allow the OraOperator to fetch the wallet for you and have it within OraOperator for you to work with. So what we're going to do is we are going to generate this YAML. Fortunately, we have some convenience shell scripts that allows us to create those YAMLs, and we are going to take a look at the YAML. So what we are doing here is we want to apply this YAML, which is basically going to bring the wallet of that database that we just created to OraOperator. Okay, so we are passing the autonomous database OCID. We are saying instance wallet, and we have an instance wallet password, etc., etc. So let's apply this, and then we can verify that we have the wallet within operator. Yeah, I'm going to apply this like this. All right. Apply. And now that I applied it, I can actually go ahead and try to fetch the secrets related to instance wallets to see if they are there. So I will do kubectl get secrets. That gives me all the secrets, but I do a pipe, so I grep for instance wallet. And I should see two, okay? One secret is the password itself for the wallet, and the other one is the wallet itself, right? So the wallet is there. All right. So what we're going to do now we are going to initialize the database because we have this autonomous database up and running. We have the wallet of the autonomous database up and running. But if I want this database to run with Cloud Bank, I need to have the necessary roles that Cloud Bank expects. I need to have the necessary users within the database that Cloud Bank expects. So what I'm going to do is I'm going to init the database, and this is going to run SQL over the database using the wallet that we just extracted, and using a direct connection to the database. It's going to run SQL, and it's going to create all the roles and users that are necessary for us to support the application, which is Bank Cloud. So I'm going to do that. And now I'm going to show you the log of this application so you see what happened, okay? Let's wait a little bit. Right. So I'm going to do nano logs. And I'm going to do 2117. And as you can see, we did several grants within the database. We created a queue user, which is, advanced queues. We created the bank user, which is the main user of the microservice. And we created the bank B user, which is the other user. We ran a few procedures. We created a table called accounts, which I'm going to show you in a couple of minutes, okay? So that's what we just did. We basically enable the autonomous database to run with our application and to have everything that is necessary for our application, okay? So let's do a scaling exercise. I have a YAML here. I'm going to show it. Okay, I have a YAML here that is basically saying, okay, I have Cloud Bank DB. It's an autonomous database. This is the OCID. So this OCID will have to change because it's from a previous run. And I want it to be 2 cores right now, 2 CPUs, and I want it to be 2 terabytes in storage, not 1 and 1, but basically 2. So what I'm going to do right now is I'm going to get the OCID of the database. You can go here. Let's see if I can copy it. You can copy it from here, or you can also use the command line to actually fetch it. And I'm going to go here. I'm going to delete this one. Okay. Because this is from a previous run that I did, that terminated database that you saw, right? So this is the right OCID. I'm going to save. Now I'm going to stay here because I want you to see this, okay? Now I'm going to apply this YAML, which is basically saying, hey, this database, 2 cores, 2 terabytes instead of 1, 1, all right? So let's apply the YAML. So as you can see, we've been just applying YAMLs since we started. Very easy. The YAML is the spec, and we apply them, and things happen, right? All right, so I'm going to apply this YAML. Okay, so it says configured. As you can see, we just immediately saw scaling in progress here. So it was automatic. We did this scaling via YAML. Things started to scale. And now, if this goes okay, we will see 2 OCPUs, 2 terabytes, right? But one of the good things is that there's already like an underlying spec there for the autonomous database. So here we applied like a new one, but we can also just patch the existing spec. So I will wait a little bit until we get these 2, 2 and 2. But basically, then we can say kubectl patch and pass, the specific fields that we want to change. We might want to scale this database back again to being 1 and 1, 1 CPU, 1 terabyte, and we can just patch the existing spec. So OraOperator has a reference to that spec. We don't have to provide new one all the time. We can just edit or patch the existing spec to make the database be what we want it to be. Okay. All right. So we could also do this from the command line. kubectl get ADB cloud bank, and we will see here state scale in progress. Okay, we'll see the scale in progress. There you go. Now 2 CPUs, 2 terabytes, and scaling. Now it's available, right? So what I was telling you about the patching is that, let's see if this works, because I have never tried it. But basically, we can rely on the existing spec for the database and do something like this: kubectl patch autonomous database cloud bank, CPU core count 1, data storage size 1. So basically saying, take the spec that you already have and patch it with a new CPU core count and new storage size in terabyte. So I never tried this before. It says patch it. Let's see if it reflects in the operation of the database. Okay, so let's see. All right, it says scale in progress. But here I don't see it. Oh, there you go. It updated, scaling in progress. Okay, so the patching worked. Okay, now we're getting it back to 1 CPU, one terabyte storage, but by just patching the existing YAML spec for the database. Okay. Okay, so we are running out of time, but I just have one more thing to show you, which is basically connecting to this database. We can use SQL.cl or SQL Plus, but for that, of course, you need the wallet here, right? In the system, we're in Cloud Shell, we need the wallet here, because otherwise we won't be able to connect. So what I'm going to do is I'm going to source an struct wallet shell file that I have here. I'm going to source it and I'm going to show it to you. Okay, source struct wallet. Okay, and that basically took the wallet, fed to the wallet, and put it in one of my local directories. And if I go nano struct wallet, you can see that what we're basically doing is putting the files, TNS names Ora, SQLnet Ora, wallet, all the wallet files in our TNS admin directory, local directory, which is Oracle Network Admin. That's what I'm using. Okay, and this is the way in which you extracted from the operator. We are not connecting to OCI directly to fetch the wallet, but we are connecting to the operator, and we are saying, hey, operator, hey, Kubernetes, give me these secrets that you already stored as this being the wallet for the autonomous database. Okay, so we're getting it from the operator, and this is really good because if we are all orchestrating things and working with CI/CD, we don't have to do explicit connections to OCI, but basically work 100% with the operator. Okay. All right. So now, just to wrap it up, we're going to use this wallet to connect, and then we are done. Okay. So now I want to connect and I want to do SQL Plus, for example, could be SQL.cl, just SQL, you know. I'm going to do SQL Plus and I'm going to do admin at, but I need the name of the database. And I think that it's right here, okay? DB name. Okay. And I'm going to use medium, so I know it's there. Okay, so let's see if everything is okay. Okay, let's see if it works. Okay, and now I have something very important to tell you. I think that there's a bug in this project where the password that I passed in lab 1, which is I set a specific password, admin password that you probably saw as secret. I mean, we actually created the secret in this session, but that password was passed before in lab 1. I'm not sure if there was an issue or if there's a bug, but that password did not got applied, and a standard default password that is somewhere there in the project got applied, which is welcome 1, 2, 3, 4, 5. Welcome with a capital W, and then all non-capital, and then 1, 2, 3, 4, 5. And this is what I'm going to enter because I know that there's a bug here. I'm going to try to contribute back to fixing this bug if this is a bug, or otherwise see what's going on. But as you can see, we managed to get into this autonomous database, right? So right now what we can do is, for example, we can select all the users to see the users that are there. And we can see, for example, right there at the bottom, we can see bank A user, which is the one that we created when we initialized the database. And now we want to see what tables bank A user has, and now I'm selecting table names from all tables where the owner is bank A user. And we can see accounts. And remember that when I show you the logs, we created the accounts, okay? The accounts table. And I'm going to now select from this table. And here you can see basically the account balance. Suppose that these are dollars, right? And the account value, suppose that these are dollars. Now, we don't have time because we ran out of time. We don't have time to deploy the application, but basically we are missing just deploying 2 scripts that deploy the application, gives us a public IP that we can go with a UI interface where we can actually transfer money. And we can say transfer $10 from account A to account B, right? We do that with the UI, which is basically the application that being supported by Autonomous Database. It's Cloud Bank. And I would basically come back here, just query the database again, and show you that the values are moving, right? That the values are being applied, right? And that we are extracting money from the account, okay? Okay, so that's it for me. Stay tuned for a part 2. Well, we will do the Jenkins stuff. We will obviously also deploy the application and go ahead and take a look at the specific example where we will be doing GitHub hooks for branching and connecting to Jenkins and creating and destroying databases on demand. Okay, and then part 3, where we will see the observability controller that will be soon added to the OraOperator. I think, Nikki, that we can go straight to you for you to wrap up.
So with that, I'll go ahead and end today's session. Have a good day and hope to see you soon.